MacMaths, let's do some maths today. Okay guys, this is just a quick follow on from my Solving Harder AS trig equations, and this is support with exercise 10E. So the harder trig equations are covered with exercise 10E and 10F. So I've done a lesson to help you set you up for 10E, and now I'm going to go through some of the questions. I'm actually going to go, there are 7 questions in the exercise. There's lots of parts to them, so there's actually a load more than just 7 questions. But I'm going to go through 4 today, and the 4 that I'm going to go through tell the story of the whole exercise. So if you can understand these 4 that I go through, you should be able to do all of them in the exercise because they're all very, very similar to these. Okay, so let's start these straight away. I've got 2 more here, but I've just covered them up so they don't get smudged. 1a is sine 4 theta is equal to 0. Very similar to the example that we've done, and hopefully you've just watched. Okay, so I don't use the cast wheel for this. I use the actual graph. Okay, because I'm at the limits of 0 and 1. You know, in this case 0. So where is sine theta equal to 0? It's here 0 at 180 and 360. Okay. So when I inverse sine this, I get 4 theta is equal to, and the values for 0 are 0, 180 and 360. But if you remember from my video explaining this, this is a squash, so it gives us 4 times as many values. We're going to end up dividing all of these by 4, aren't we? Okay, so we can afford to go 4 times the 360. Right the way up to 1440, because when we divide that by 4 we get the 360. So what we're doing is we're going round once to 360, twice to 720, 3 times to 1080, and 4 times to 1440, and then we're dividing all of those by 4. So let's keep going. We're going to go 0, 180, 360, we're going to go 540, another 180 degrees, okay, and then we're going to go 720, let's have the 900 after that, 1080, I've run out of space here, 1260 and 1440 degrees, okay, and then I'm going to divide all of those by 4 like we would do with a normal equation to get our values of 0, 45, let's put commas between them, 90, 135, 180, 225, 270, 315 degrees and 360. And if this was in an exam, of course, I'd put me little notes on the end there, just to make it proper, all good and proper. Okay, so we've solved sine of 4 theta is equal to 0 between 0 and 360 degrees, okay, and this time it does include the 360, so just be careful, and the 0. 2a is the tan of 45 minus theta is equal to minus 1. Okay, straight away I can inverse tan of both sides, and when I inverse tan of both sides, of course I get 45 minus theta. Okay, and let's have a look at 1. So I'm not going to write down the value here now. I'm going to go straight to my cast wheel. So in an exam I'd quickly draw this, I always do. It's got a bit smudged there, my cast wheel. It's just tidying that up. That's my 90 degrees for when I go round clockwise, but I've also done it anti-clockwise. I've got a little bit of experience here. I can see that I'm going to be left, when I take 45 off both sides, I'm going to be left with a minus theta. So I'm going to multiply both sides by minus 1, because I don't want a value of minus theta, I want the value of theta. Okay. So I'm going to start off with, let's have a look at all the values when we inverse sine of minus 1. Well, if you did that, again, on your calculator, if you were inverse, saying sine, tan, if you were inverse tanning it, okay, you would inverse tan of 1, and that would give you 45 degrees. It's one of those exact values you need to learn, okay? So the tan of 45 degrees is 1. So let's put it in there, turning 45 degrees. And 45 degrees into the tan region where it's positive, okay, is 135. But we don't want those two values because this is -1, okay? So we want the values, we don't want values in these regions here. We don't want those regions, okay? We want it in the negative regions for tan. So we only want values in these two regions here, okay? So we want, yes, 135 degrees, and yes, 315 degrees. That's turning back 45 and turning back 45 into sine and cos. So those are the ones that we want in these two regions where tan is negative. Okay, so let's put those ones in. 135 degrees, okay, and 315 degrees. Okay. Now I know that I'm going to multiply by -1 through, so I'm going to go use my negative wheel as well. So I'm going to go this side of my tan graph. So I'm going to go back in this region. I've got also, of course, I've got -45 degrees, haven't I? So I'm going to include that. And if I go back and do a full 360 degrees in the opposite direction, coming this way instead of that way, of course I come across this person here, which is -225 degrees. Okay, so 45 degrees past -180. So that's going to be -225. Okay, so I've done all the values from 0 to 360 and all the values from 0 to -360. Okay, for -1. Now I want to take off 45 from both sides, so like I would do with a normal equation. So when I take off 45 from both sides, I'm just left with minus theta, aren't I? So take 45 off that would give me 90 degrees. Take 45 off that would give me 270 degrees. Take 45 off that would give me -90 degrees. And take 45 off that would give me -270 degrees. Okay, so I've taken 45 off from it. It's gone down to -270. Okay. The question is asking in this range 0 to 360. So currently, you know, those are looking in range and those aren't. But look at this minus theta. We can move that to that side, becomes positive theta, and all these to this side. Or we can times through by -1, okay, because we want the values for plus theta. So now that gives us, timesing through by -1, -90, -270, plus 90, and plus 270. So these two initial values now are not in range, okay, but those two have fallen at the last into range. So those are the two values that we want, 90 and 270 for this one. Okay. All right. So I hope that's clear for you, and I'm going to go through just two more. I'll rub that out. I have drawn one, so I can sort of slot in there my little replacement if I need to use it there. Okay, you can see I've upped my game now. And the last two I'm going to go through are question 3A. All the question 3 are similar to this. Okay, and actually they're all very similar then until you get to the last one. Question 7 in the exercise is a little bit different but fairly straightforward, so I'll explain that one to you as well. Do have a go before you watch this video as well, before you watch me do them. If you're doing these now, you know, put it on pause and have a go at 3A first before you're listening to me. Okay. So we are looking at this one. What are we doing? Oh, I thought I've done 3D in my example above. So anyway, we'll do this one here. Fair enough. So I haven't got this written down, so I'm going to have to work out these values. Both sides, divide by cos 3 theta. Okay. When we divide by cos 3 theta, I might not even do this one, we get 3 tan theta, as you know. Okay, because we've got sines and coses. And divide this side by cos theta, and we've got 2, and we've got tan 3 theta is equal to 2/3, haven't we? Okay. You'd have to reach for your calculator then. I haven't got this one written down, I haven't worked this one out. So shift tan of 2/3, and it's positive, so that's easy, and that is equal to 33.7 degrees. So 3 theta, remember, is equal to 33.7 degrees. Okay. It is in the range, let me just check, but yeah, between 0 and 180 degrees. Okay, so remember we've got to find the other values. So we want, it is positive, so 33.7. We want this one here. So if we add 33.7 to this one, we're going to get 213.7. So 213.7 degrees. Okay. But what you want to do is, just checking that region is 0 to 180. You want to keep going round, okay? So we want to do it 3 waves, okay? So I'm going to go round again. So I'm going to go 360 plus 33.7. So 360 is going to be 393.7. So that's my 360 plus another 30. And then I'm going to go again. So 360 plus 213.7 is 573.7, and I want to go round, you know, another one, so I'm going to go also equal to 360, 720, got all of those values up to then, 720, 753.7 degrees, and 720 plus my 213.7, that's 1, 2 plus another 213, and that gives me 933.7 degrees. Okay, so now all I'm left to do is divide by 3, okay, for all of those values. And I'm just going to do that last one because on my calculator you can see actually when I divide, that's 311, that's going to fall out of range. Okay, so 33.7 divided by 3 is 11.2 degrees. 213.7 divided by 3 is 71.2 degrees. 393.7 divided by 3 is 131.2, and we're getting close to the limit now, aren't we? And I think this one, 573.7, is going to be out, isn't it? Okay, it's 191, so we don't want any more. So it's just those 3. We do not want that divided by 3. You can see now takes us out of the range that they're asking for. If this had been 360, all of these would have been included. Okay, but we don't want those. Okay, so that's 3A. If you're doing these, the one that I had written down for you is 3D, which is, it has sine of x minus 60 and cos of x minus, just divide through by cos of x minus 60. It's the same as, is actually the same as this one. Okay, so you should be okay with that. But message me if you're not. Okay, I'll show my homework. And then the last one, it's not quite worded this way because I've shortened it. It says that tan of kx is equal to minus 1 over root 3. Okay, where x is 60. Okay, so this here is telling you is 60 degrees, x is 60 degrees. 1 over root 3 is actually one of those exact values. Okay, it is the exact value for 30 degrees. Okay, so that is the exact value for 30 degrees. Okay, but the fact that it's minus, okay, it means that for tan it's not this one here, not the 30 degrees. We don't want that one. We want it in this region, you know, or this region, don't we? 30 degrees into here, or 30 degrees into this region. Not the ones that are positive for tan, but the ones that are negative for tan. Okay, so 30 degrees is the same angle as 150 degrees, is the same angle as 300 degrees. Okay, so when we inverse tan that, okay, we get 150 degrees, don't we? Okay, the minus, that's going to give us 150 degrees. But we know that the tan of kx, where x is 60, well, we know that the tan of k times 60 has got to give us 150 degrees. Okay, it's got to give us that 150 degrees, hasn't it? So got to give us the tan of 150 degrees. So this k here must be, what do we times 60 by to give us an angle of 150 that would give us a tan ratio of minus 1 over root 3, which is actually the value for 30 degrees in this quadrant. So k has to be 2.5. You do 150 divided by 60, you get 2.5. So find possible value for k, a possible value for k. 2.5 is good enough. Okay, that would give us this angle here. Okay, so 2.5 lots of 60 would give us 150. The tan of 150 would give us minus 1 over root 3. Okay, so k could be 2.5. It could also be, you know, what value gives us, so 300, 300 divided by, I can't believe I'm doing this on the calculator, 60 is equal to 5. So k could also be equal to 5, couldn't it? 5 lots of 60 would be 300. The tan of 300 would be minus 1 over root 3. Okay, so k could be 2.5, it could be 5. But it just says find a possible value for k. I think that's the answer it gives you in the back. It doesn't say part B, it actually says state with justification whether this is the only such possible value of k. In other words, justification, give a reason and so. Well, no, it's not, is it? Because we just found another one there, and in fact, there's not a range attached to this question, so there's an infinite number every time we come round to this position here. So 360 plus another 150 is 510 degrees. So whatever we times 60 by to make 510 degrees is another value for k. There's an infinite number of values of k, isn't there? Okay, and we just found one of them. All right, so that's okay. You should have a good go at exercise 10E now. You know, it's all, you know, fairly sort of straightforward from there on. Okay, so just message me if you're struggling, and my next video will be looking at the other trig equations, the harder ones, okay, in 10F, and they are the quadratic ones. Okay, over and out. Thank you.